Welcome back to Maths with Mrs. J. I'm going to start a series of videos about index laws. I'm going to cram a fair amount of information into just a few videos. Bear in mind that generally speaking, index laws are begun towards the end of primary school, and probably by the end of year 10, you would be expected to be in relative mastery of negative fractional indices, being able to manipulate back and forth between using the square root sign and all that sort of thing. So this covers a number of years worth of work. You do need to do a significant amount of practice in order to master these skills. Let's begin. If we're starting with this expression, what do we call each bit? Well, the A is called the base, the X is called the index, the plural is indices, and the whole thing put together is called the power. Now, here are our first lot of index laws. If you are multiplying powers of the same base, you add the indices. If you're dividing powers with the same base, you subtract the indices. Let me just show you an example as to how that all plays out, just down here for a minute. So a squared is 2 factors of a. Times a to the 4th, you've got 4 more factors of a. So we've got 2 factors of a and 4 factors of a. So altogether we've got 6 factors of a. That's why, in essence, you're adding those indices, because that's telling you how many factors you've got. And obviously, if you're multiplying, you're having that number more factors. If you're dividing, it's probably easier to think of it like this. So you've got a to the 6th. So you've got 6 factors of a. 1, 2, 3, 4, 5, 6. And you're dividing by a squared. Now what happens here is you're cancelling off 2 factors and you're left with a to the 4th. So in essence, that's why you're subtracting your indices, because of that cancellation process. A to the m to the n is an extension of that first index law. If you've got n factors of a to the m, it's like a squared by a squared by a squared by a squared by a squared. You're going to be multiplying those indices. And these last 2 index laws for this slide anyway, is if you have a product or a quotient raised to an index, you are allowed to bring that index in to each of the factors or each of the parts of the quotient. That does not work if you have a plus b or a minus b raised to a power. They are different entirely. Let's work through some examples and see how we go. All right, x squared by x cubed. They are powers of the same base, so we add the indices. Here's an example where we happen to have a coefficient coming in as well. All you've got to do is just multiply your coefficients. 3 by -2 is -6. X to the 5th by x to the 4th, we add those indices and get x to the 9th. This next one's a very similar thing. -2 by -3 is +6. A to the 5th by a, well, a is really a to the 1, isn't it? So 5 plus 1 is 6. B cubed by b to the 1 is b to the 4th. Okay, we're going to bring our index into each part of this product. So 2 to the 5th is 32, and c cubed to the 5th, we're going to multiply those indices. Same sort of deal here. 3 cubed is 27. A squared cubed, multiply the indices. B cubed is just b cubed, obviously. Okay, -2 squared is +4. X to the 4th squared is x to the 8th. We multiply the indices. Y to the 5th squared is y to the 10th. Again, we multiply those indices. Okay. Let's get rid of our brackets by bringing in that power to each bit. 2 squared is 4. A cubed squared is a to the 6th. B squared squared is b to the 4th. A to the 5th and b to the 15th. And then we're just going to tidy up. So we're going to get 4. A squared by a to the 5th is a to the 11th. B to the 4th by b to the 15th is b to the 19th. When you have a quotient like this, I like to deal with the number part, then the A part, then the B part. The number part, we're going to cancel and we're going to be left with 4 in the denominator. So let's sort that out. A to the 5th divided by A cubed, we're going to subtract the indices and be left with A squared. B to the 6th divided by B to the 5th is B to the 1, which is just B. So I would normally write that with the 4 in the middle, just looks a little bit nicer. There we go. Now, this next one is almost the same, but you'll notice I've got a b to the 7th instead of a b to the 5th. So we're still going to get our a squared in the numerator and we're still going to get our 4 in our denominator. With ones like this, we are going to learn about negative indices in the next video. However, the easiest way to do this is to locate where the bigger power is. Now, in this case, the bigger power is b to the 7th, which is in the denominator. Then do that divided by the other one. So b to the 7th divided by b to the 6th is b to the 1, and leave your answer where you started. So if you start in the denominator and you're doing denominator divided by numerator, you put your answer in the denominator. If you start in the numerator, so a to the 5th is the bigger power, a to the 5th divided by a cubed is a squared. That's why the a squared goes in the numerator. Okay, last one for this video. So that obviously doesn't need to have anything done to it. Bringing in our a cubed to each bit. Bringing in our power 5 here. B squared to the 5th is b to the 10th. We're going to bring our squared in. Tidying up a little bit. Well, the 2 will cancel with the 4. And we've got negative a squared by a to the 5th is a to the 7th. B to the 1 by b to the 10 is b to the 11th. Over 2. A cubed by a to the 4th is a to the 7th. B cubed by b to the 6th is b to the 9th. Now these a to the 7ths go completely. They cancel out completely. Then we've got b to the 11 divided by b to the 9 is b squared. So negative b squared over 2 is our answer. And there you have it.